And we're going to use systems of equations to investigate profits. So example 10 says, given the cost function c of x equals 0.85x plus 35,000, and the revenue function r equals 1.55x, find the break-even point and the profit function. So we want to know where r of x, there it goes, where r of x equals c of x, and that's going to be where 1.55x equals 0.85x plus 35,000. So I'll subtract the 0.85x, and I get 0.70x equals 35,000. And I can divide by 0.70. X is 50,000. So at 50,000 units, they'll have the same cost as revenue. Now our profit function, I guess we can figure out what is the revenue. So R of 50,000 is going to be 1.55 times 50,000, and that would be 77,500. The next part, it asks for the profit function. So profits, if I can write correctly, be helpful. Profit in terms of x is going to be revenue minus the costs. So it's going to be 1.55x minus 0.85x plus 35,000. So I can distribute through and subtract. So that's where we get our 0.70x minus 35,000. I want to show you one more thing on this. Is I did go into Desmos and I put these two equations in. Turn that off. So, and I changed my window. Remember, we changed the window. Can I change this? Okay, you use this little wrench button to change the window. So notice it goes up to 66,718 on the X, and it goes up to 95,000. And that's just so we can really see what happens kind of more in the, well, not quite the center, but it's not right on the edge. So if I turn on my cost function and turn on my revenue function, I can see it crosses here. And Desmos is really nice. You can just tap on that. It finds that intersection point at 50,000, 77,500. So, okay, let's go on to the next problem, which is example 11, and our final problem. The cost of a ticket to the circus is $25 for children and $50 for adults. Jeez. Circuses have clowns, so that makes it even worth less. One on a certain day. So children, so we could say 25 times C plus 50 times A equals, and so this is the money derived from each of these. So on a certain day, attendance at the circus is 2,000. So C plus A equals 2,000. And total gate revenue is 70,000. So $25 per person, per child times C children, plus $50 per adult times A adults is 70,000. So one equation gives us the number of people, the other one gives us the amount of money. So this is people, money. But we have two unique equations and two unknowns. So if we have this 25C plus 50A equals 70,000, and then we have our C plus A is 2,000. Pick one to get rid of. I think the easier, it really doesn't matter. But I'm just going to get rid of the C, so multiply by negative 25. And I'd have 25C plus 50A equals 70,000. Negative 25C minus 25A equals, and I think that's 50,000. Negative 50,000. Now, we could have done a substitution as well on this, honestly. It doesn't matter. This was what I thought was good to do. And that's 50, by the way. 50A minus 25A is 25A. 70,000 minus 50,000 is 20,000. Divide by 25. A equals, excuse me. Let's pull out the calculator. I should be able to do that in my head, but I'm not going to. Thinking it's like in the 400 range, but let's find out. Yep, I'm glad I didn't because it's 800. 800 adults, and we know that C plus A is 2,000. So C plus 800 is 2,000. Subtracting 800. C would equal 1,200 children. So we have 800 adults and 1,200 children. Okay, and that's it. This could have been solved, like I said, with substitution if you wanted to do that instead. Could have solved for C or A, and that C plus A is 2,000 and substituted in. So it's really it's the preference of the person doing the work. So okay, that's it.